Good morning. How's everybody? I hope you're doing well. I hope you're getting through the material during the week. If you need, after, like I mentioned last time, if you need additional help after we review this material, let me know and I can make arrangements either for the TA or for you to meet with me. But please do your due diligence, means read the notes and watch the videos and really give it a try so you can identify your problem areas. And usually students just have the same recurring problem, and once that's corrected, there's no problem anymore. So that's what I ask you to do. So this is our first stab at it. I gave you a number of problems to solve, and I wanted to pick that up. I just wanted to do a quick review of the formula sheet and remind you what to look for. I'm gonna wait till at least I have 20 people. Let me see. We're at 15. Morning. Thanks for the sunshine. It's been rainy, dark, but I don't know. Is it gonna be a nice weekend? Are you guys going to celebrate this weekend? How's that going to work out? I have no idea how people are dealing with the restrictions. I don't even go out. I just stay in. I'm busy anyways. I've been super busy since March 13th. And I'll probably go out for something to eat in an outdoor place and then come back home and work on things. Sleeping. Yeah, make sure you put a little bit of studying in there, but take some day to refresh, reboot. It's not a bad idea. Okay, 16, 17, 3 more people. So the last feed, the last live stream worked out. The captions appeared, and the chat was there. So that was great. I was happy to see that. I didn't do the timestamps yet. That'll make it easier to review when you come to the point of wanting to review the video again. So I gotta put those in. Those are really fancy. I really like doing those. It's just a matter of time. Okay, so we have 19 people. So this is the formula sheet. As you remember, I told you to work from the base. You can recopy the formula sheet, making your own notes on a sheet of paper. Make sure you write it down in your own handwriting, okay? So you practice writing everything out. So here we have the basic time value of money. You have the basic time value of money formulas here. Oh, let me do that again. You have the discounting one and you have the accumulation one, but they're basically the same formula, solving for different variables. And then the other variables inside you can also solve for it, but I don't create formulas for it. I just taught you how to solve for them both analytically, like isolating one of the variables, or I taught you how to use your calculator to get them, and how you have to be careful about keeping track of the cash flows, the signs on the dollar amounts to get the right answer. Then there's the NPV formula, and we use this for net present value calculations and mixed cash flows. It's just, all it is the discounting formula again and again and again, right? That's all we got going on over here as the present value of future cash flows, and then that's offset by the initial cash flow, which is a negative usually for investment projects. So that aligns with this timeline. So what's the timeline? There's no payments in the first one. It's just a lump sum amount, either here or, so either as the present value or the future value, and you solve one or the other, or some of the variables, I or T. For the net present value, it's the initial cash flow is a negative, and then these are whatever they are. They could be positives, they could be negatives. Those are the future cash flows. And we also taught, I also taught you to do this for mixed cash flows. So if you have amounts, you can actually solve for the fair price of an investment when the cash flows are different. When they're the same, however, and you have a certain pattern, you can use these simplifications. This is the first pattern we learned. This is the pattern where the first cash flow comes one period from now, and then in future, every period, it's the same cash flow forever. From there, we get our base formula. And I proved how you can derive this formula, so you can look back at that video if you forget, and that's the perpetuity formula. That formula represents only the stream of cash flows. Then I introduced the idea of what if they're not exactly the same cash flows, but they're related. And how are they related? They're related by a constant growth rate. If they're related by a constant growth rate, then the first cash flow, again, one period from now, okay, so there's nothing until one period, the end of the period from now, and then on the following period, the growth kicks in. So if you have exactly this pattern and this growth goes on forever, this is the formula. It just looks like the perpetuity, except the denominator is smaller. When the denominator is smaller by an amount, minusing off the growth of the cash flow, what happens is the overall number is greater. Okay, so this is going to be a larger amount because because your cash flows are growing, it reduces the erosion effect of the time value of money. This only applies when I is greater than G. If I is not greater than G, then you have to draw the timeline and figure out the pattern yourself. If I is not greater than G, you're going to realize that the pattern of cash flows blows up, and this amount will be huge, infinite, and in so many words, will not exist. So that will not, so that's just letting you know that. Annuities, the formula are for a set of cash flows that looks very similar to the growing perpetuity, except they end. It doesn't go on forever, just T periods. So there's an adjustment effect. This is the adjustment factor here. I showed you how to derive that, but basically you're going to use the formula to write down the expression with the values inside, and then you're going to use your calculator and the TVM keys to get the answers. You can solve for different elements of the formula, and we're going to get into that with the exercises that we solve. The last formula I gave you was the growing annuity. So this pattern is like the growing perpetuity, except that it ends. So I put this term on here just to remind you that the growth does not start until one period after the first cash flow, which is also one period after the first, one period after the valuation. So you want to get the value at 0. The first cash flow is one period from today, and then the growth kicks in. So this formula, I also derived this formula for you. The formula I didn't put on this is the annuity due formula, but I showed you 3 methods, and you can add it onto this formula sheet for yourself. Remembering the growing annuity formula only applies if I is not equal to G. If I and G equal, the formula disintegrates, you can't use it, so you have to use a different method. Draw the timeline and interpret the effect of discounting. So I gave you an example of that. So the only thing missing here is, well, there's a lot of other formulas you're going to see, but the annuity due formula, I didn't put it on here, so you can add it. Okay, you can add the one that you like, actually. I'll just say add. So you can add all the formulas you want. It's just for you to study, but I'm just getting you a start, okay? And make sure you keep track in your mind of the formula with the timeline. They go together, they're a pair. I also said for the test situation, I want you to draw the timeline. I want you to draw timelines when the problem is complicated or when you have payments. That way, if you make a mistake, because there's multiple steps, I can see what you tried to do and give you part marks, maybe. So you'll lose points for interpreting the problem wrong, but I might give you credit for being consistent with the rest of your solution. Okay. So that is a formula sheet. So where I want to start then is looking at the review exercises. Now these were straightforward. What I'm going to ask you is which ones you want me to do, because I want to get an idea of which ones give you trouble. Okay. So which ones do you want me to attempt? You have all the answers, but which ones did you not understand? Okay, so the first paper was straightforward. Most of you understood. Let's see. Let me hear from at least a few of you. Ariette wants the other paper. Okay. If I don't have to solve these, that's great, but if you need help, I prefer to help you, so let me know. Okay. Okay, so yeah, discounting inflation is lacking a few things. I just wanted you to think about it before I did it. So I will do that entire page with you and then send you the nice printed out solution. So don't worry about that one. So everybody's good with 1.2. Anybody else want to tell me? There's 10 people missed, so only a third, 2/3 of the people in the class are here. Like there's 30 students in this class, so I hope those people don't need help. So that's why an incentive to show up to class is you can ask me what you want me to do in class if you want me to solve certain problems. If you cannot attend the lecture live, you could write me an email and let me know if you want me to address something, and I can put it in the video so you can look at it later, right? Okay, so no questions on this first assignment. Question 4. Okay, let's do question 4 for Raphael. So this one, I'm going to see if I can put my iPad up. For some reason, I still don't have my new iPad. I'm waiting. 1 more week, I'm told. Pray, pray, pray. It shows up. Where was I? Let me see if I can get it going. Let me see if I can. not sure. I don't know why it's not showing up. Very strange. All right, I'm going to just use my solutions, I guess. I don't know why that's happening. Okay, I'm going to start playing with this. And, okay, so number 4. See that? Okay, so number 4, what did I do here? I read the problem. I'll read the problem first. So a couple requires $100,000 in mortgage financing. So this is the loan, the present value. The effective monthly interest rate is 1%, and it has to be monthly effective because the payments are monthly. See, monthly payment that they can expect to pay if they accept a mortgage with a 20-year term. Okay. So you want to calculate the monthly payment. So this is the formula. And here's the present value. Here's the monthly rate. And you have to convert to months. So 20 times 12 months in a year makes 240. So that all makes sense. So all you have to do, you see, is now enter that into your calculator. So let me flash up the calculator. Oh, I see what I did wrong with the iPad now. Okay, let's see if this works. I missed a step with the iPad, so I'm probably going to be able to do it. So entering this, just going to show my keys at the top. So from left to right is going to be 240, 1, remember you put it in as a percent. PV is what you get at the outset, right? So, oh, sorry, that's the loan amount. So it's a cash inflow, so it has to be a positive. And the payments are what you make, so those have to be a negative, which I want to figure out, so leave that alone. And the future value I put in as a 0, and then I just ask to compute payment, and that's it. So what did I get? Yeah, so it's right. You see that? Questions, Raphael? Right, okay, so that's why I did it, just to clear that up. Right, so your present value, the loan amount you're getting today, so if you look at the time, well, I don't have the formula here, but usually, yeah, the time 0, right? The formula is at time 0, that's the amount. So that can help you too. Those subscripts aren't meant to confuse you. They're meant to help you. So let me see if I can. Oh, I closed that sheet. So in using the annuity formula, notice that it says 0 here, right? So that's now, 0 for now. There's no FV. There's no FV, or FV is treated as 0 for this problem. I could also, I could figure out the value in the future. That's another thing I can do, but that is just treated, if I want the value of an annuity in the future, well, the annuity value is just an amount. In this case, it's 100,000. If I wanted to figure out the value in the future, what I would use, because the PV is just a single amount that represents all these payments here, if I wanted to figure out the future value, I would just use this after, okay? So I don't introduce a new formula for future value. If you guys have seen that before, there's no point because it's just using the basic time value of money formula. It's more important for me to make you realize there are only a few distinct formulas. The 5, well, how many do I have here? 1, 2, 3, 4, 5. There's only 5 formulas really for this class. I mean, for these basic time value of money problems. There's a few other formulas I'm going to teach you for sure, but these are the basic ones to do time value of money. Okay, so that'll make sense to you for problems when we get there. Okay, so you got that. What I want to do now, so we did that. Let's look at the second handout. This is really an important one. They're all important. But it's important to realize you can get the answer various ways, but I specified that I want you to use annuities, okay? I want you to practice using annuities. All right, so let me flash up the solutions. So I gave you the answer, but I didn't give you the solution, right? I gave you the answer, but until I gave you the worked out solution, you didn't have that. So what I wanted you to do here, receive, okay, let's see, you asked for the different one, but let me just look at this one first. Does anybody want me to do the first one, or actually I should just ask? Which one on the annuities do you want me to look at? Someone wrote number 4. How about 1 and 2 and 3? Okay, the second one. Okay, so let me just overview the first one, okay? So what I did was I drew the timeline, right? I said for payments, make a timeline. Now this is for me to explain to you, realizing if you just focused on what's going on, oops. If you just focused on what's going on over here, these cash flows look like an annuity. They create an annuity with the present value at time 3. So if I just focus my camera on that portion of the timeline, that's an annuity. So that's why I use the annuity here, but I don't have a subscript of 0. I have a subscript of 3, because remember, the first cash flow has to occur 1 period after the valuation, like when you want the price of it. So the value is determined 1 period before. So that's the annuity. So I reduce all these cash flows to a single number. That it is. Oops. That it is. It's 3,992 point, and I leave all the decimal places. So what you should do with that, and that's not clear here on this, so let me tell you now. What you should do with that amount is not write it down with all the decimal places. You store it. So we can do that and put that in storage. Use store 1. Okay, so you're going to put that in store 1 in preparation for the second part. The second part is, now that I have a lump sum amount over here, I have a lump sum of almost $4,000 here, but I want to get the price at time now. So this is actually just a basic time value of money discounting problem. That's why I use the first formula you learned. Or some of you learned it, some of it, most of you it was a review. So I put this, even though the formula says FV3, I use PV3, just, I don't know, you could put FV3 there as well. But they are the same thing. Remember, every item is both the present value of something and the future value of something at the same time. So I'm going to use the PV3 in the notes. What I do is I can store it from the part here, and then I can either use my TVM keys and say, and going from left to right, I put 3 into N, and then I put $8 into interest, and then I want the PV, so I'm not going to put that, and I put in, there's no payment, so I put 0 into payment. Again, you guys can use the time value of money keys on your calculator, or you can you can punch this in analytically. I'm not going to watch what you do, but I want you to practice using the financial calculator, because you're going to need it for some problems, and there's no other way to solve it unless you use the calculator. Okay, so that's 0. So then I put in the future value. The future value is recall 1, and you put that in. Oh, I have to put as negative on it, or no, it doesn't matter. I know what I'm doing. I'll leave it like that. Yeah. So recall 1 into future value. You guys following me? Can you see all that? And then you ask for compute PV, and you'll get the answer. So why am I doing that? We have to have the same decimal places, right? You have to learn how to do it like the banks and the financial institutions do it, to get exactly my decimal places. If you don't have my decimal places, probably it's because you just typed in this number here by hand manually and you missed the decimal places after. The calculator stores 25 decimal places and computers can store more. Okay, so obviously it's not going to make too much of a big deal with just like just 3 periods like are here. But when in real life, in reality, remember for mortgages or loans and they're made by month, you could have hundreds of periods of compound interest, and that's going to affect the decimals. For credit cards, where compounding is daily, you're going to have hundreds of periods of compounding. Okay, so you got to get into the habit of using the calculator properly. Okay, so practice that technique. Make sure, even though you did this analytically, you just punched it in your calculator and you got almost the same answer. That's not good enough. Okay, you need to get exactly the answer. Hola, Carlos. All right. Now, Jennifer asked for number 2, I think. And 4. Yeah. Okay, so let's look at the second one, unless you have a question. Now here's the second one. So this one, you have the first cash flow coming 1 period from now. So that's good. So that makes an annuity. But then the cash flow changes. Now the temptation is going to be just use the mixed cash flows formula to solve this. But I don't want you to. I want you to do 2 annuity case. I want you to use 2 annuities. So the first annuity is with the 2000. So here it is. Well, I did them out of order. Let's start with the later one, all right? So we're going to start with the 3000. So I'm going to start over here with the 3000. So you have 2 starting at 4. So the value would be 1 period before the $3,000 at end of period 4. So that means I have a 2 period annuity of $3,000 at 10%, and I get this amount. You should store 1. So practice while I'm doing this. Don't just watch me. Make the most of our time together. So store 1. Then what you want to do is you want to find the value of that now, because you want to convert that lump sum amount at time 3 into a value today. So the way you do that is use the basic time value of money formula and discount this. So we do this just like I did up here. Let me just copy this. Oh, that didn't work. See if it works. Nope, didn't work. Okay, well, I'll just do it again. So yeah, you might just want to type that in your calculator, or you say 3 into n and 10, right? It's 10%. 10 into I by Y. And the present value is recall. So I'm going left to right. Recall 1. There are no payments because I've reduced it to one lump sum. So 0, you have to put 0 in payment. So I put it in the wrong place, right? This is future value. This is what I want to calculate. See, I make mistakes too. That's what we want to calculate. And we put recall. It's basically what we did. It's the same as what we did above. And then I put recall 1 into future value. And compute PV. So that should give me this amount. I'm not sure what you did, Von Mairi. In the counting process, it's important to start at 0 because I start at 1. You have to find, I'm not sure what you mean, but you need to find the value at time 0. So anyway, maybe you can clarify. All right, so now all I've done is calculated this. I need now to do this for the 2000s. So let's get the present value of the 2000. Now that's easy. It's just an annuity of 2000 for 3 periods. So it's 2000, 10%, and it's 3 periods. I can't seem to get that. Okay. And then when you get this, you should store it as well. Get into the habit of storing it. Store this one in number 2. So that's store 2. And then all you have to do is recall 1 or we can do recall 2 plus recall 1, and that will give you your answer. Okay, so that was just using the calculator. You need to practice. It's not, even though you should be able to do this on paper as well. I'm trying to teach you the skill. Efficiency of efficiently using the calculator. No, you have to, the counting has to start at 0. Like now is 0. Sure, it'll give you the same answer, but for different problems with different timelines, you might be off. So you have to start, the timing has to be now 0. I mean, you're changing definitions if you're going to call now 1. Yeah, you should put the 0. If you don't put the 0, just, I think it's confusing. But anyway, as long as you get the right answer and it's clear, I wouldn't be too worried. All right, is that good, Jennifer? You get it? You follow? And others? To get to time 0 is this step. This only gets you to 3. The annuity here only gets you to the time 3, 1 period before. It doesn't get you all the way to 0. So that's why you have to do a second part. we have to do 2 steps. Step 1 and step 2. So what step 1 and step 2 are just the question 1 on top. It's the same process. But then I have the extra annuity that starts 1 period from now, so I have to add that in at the end. No, you do not arrive at time 0. You only arrive at time 3, 1 period before. The formulas are all for 1 period before the first payment. If the first payment is 3,000 at time 4, the value, the price is here 1 period before. Okay? So that is what I'm trying to test you on, or trying to teach you, is to understand the conditions of these formula. To apply the formula, the restrictions or the limitations of the formula, you need to know those limitations to apply it properly. Apply all of them properly. Okay, so work with that. You're going to see lots of examples, Jennifer. So you're going to have lots of opportunity. No one asked about 3, did they? Anybody ask me for 3? Were they? I don't understand 4. That was the other one. And this is the annuity due. Same technique where I calculate the last cash flows first. I calculate those first, and then I discount them to time 0 because they're only at time 4. Then I deal with the fact that the first part of the 2000s for 5 years started now, so I have to use the annuity due formula for this portion. Also use storage, right? So store these values as you go. Oh, let me see what I did here. Did I do that here? What did I do here? I did store 1. I didn't store this final amount, did I? You would want to store this final, I'm sorry, I'm going back. You would want to store this final amount too. So maybe you would have stored this on number 2 if you don't want to lose anything, and then this one on number 3. And then, are you guys following me? And then you're going to add recall 3 and recall 1, 2. I just realized, because this one you want to store as well, you don't want to lose the decimal places. So let me give you a few minutes to clean that up. Make sure you can get those, okay? All I did was store this result so we could add it down here. So let me give you a couple minutes. No comments, questions? No comments? Okay. So you guys are fine with part 3, or you just gave up by then? I hope you understand what I did. So it's the same process again and again and again. I gave more details here, and I showed you the 3 methods to practice, the 3 methods for annuity due. Okay. What I'm going to do then is the last one, discounting and inflation. I'm going to close these up. And I'm going to open up. Ariette, go ahead. Ask me your question. Okay, let's see if I can open my iPad now. Yes, Ariette, yeah, there's those techniques, those 3 methods, those techniques are good techniques to learn, so I just put them in there. And you know what? You can use any one you want, but you should know all 3. So it's just like a trick. How would I explain it? It's just a skill, okay? It's just learning a skill. Learning to do something different ways. Wow, what example could I use? Oh, yeah, but anyway, 3 ways to accomplish the same thing. Sometimes you won't have certain information, and one technique will be better than the other one. Or, anyway, they'll all serve you for different purposes. I really wanted to stress the last one as well, because I show you that the timeline can go back into, beyond 0, back into the negatives, like to periods before with a negative. So that's the idea. You're gonna need to practice those 3, but in the test you just have to show me whatever. Show me one. Okay, I'm gonna suppress these and let's see if it sees the iPad now. Okay. So that's the iPad, but I need to also put up the question paper, right? So, how many of you did this? Let me tell you the answer. So let's see if you got it right. How many of you got it right? You should be able to solve, well, you know, the exercise with annuities, I asked you to solve with annuities, so I did want to force you to practice. You should be able to answer the question. I'm trying to think of all the questions I asked. Like sometimes I'll say use the NPV, so you have to use NPV, not annuities. So yeah, I could ask you that, but in terms of the methods 1, 2, and 3 for annuity due, I never ask you for a particular method. You just can do whatever you want to solve the problem. You just have to make sure that you give me a formula and you solve it. Okay, you have to write down the formula. I don't think there's going to be a nice way. Oh, it's going to look funny. Maybe just, no. Okay, let's just get the elements of the problem. I'm going to give you the answer, and then you can tell me if you got it right. So the answer for part A, if you did it, some people maybe didn't get this far, but the answer for part A was 4,000 $935.55. How many of you got that? Okay, so it's a matter of understanding what the difference between real and nominal are, correct? So I'm going to explain that. Anybody get that number? Just want to get an idea of who knows what real cash flows are. Remember, if you want to text me privately, you can. I'm going to put the number up. So nobody got that? Nobody. So let me draw the timeline. This is going to be messier because I have to draw and I don't like this iPad anymore. Let's see. Nobody? All right. So what we have is the information about real cash flows. So I'm going to draw the timeline with real cash flows. Ooh. My pen is too thick. Oh well, let's do this. Oh my goodness, the pen is way too thick for this. How do I? Very limited. Guess I'm gonna have to make it really big. So for real cash flows, what we have are times 0, 1, 2. No, I'm gonna run out of space, right? Oh my goodness. Do this again. 1, 2, 3, 4, 5, and 6. And that you're told that these are real cash flows, and they are $1,000 each. Right? Oh my goodness, this is so bad. So messy. I think I need to use a different software. It's a long story what happened with my software. It was very old and I tried to upgrade it and I lost it. So I am struggling now. Does that make sense? Those are thousands of dollars, right? Each period in real amounts. And so the rule is you have to use, if you have real dollars or real cash flows, so that's the rule. So until now, all that I gave you, all the problems that we worked on were nominal. They were just nominal dollars, nominal rates, okay, till now. And what did you do? You used the nominal dollars with the nominal interest rate. I never wrote the word nominal. You just, those were the operating numbers, right? Dollars in reality are just nominal. So what's the difference between nominal and real? I'm going to show you with this example. So let me finish this and then I can backtrack. So you need real cash flows with the real rate. Well, what's the real rate of interest? You don't have that information, do you? You're just told that there's a nominal discount rate of 8%. So I'm going to use this notation. RN equals 8%. And the notation for interest, the notation I use, sorry, inflation, the notation I use is the pi symbol. That's usually used. And the inflation for this question is 2%. So what that means is every year prices, so this is the assumption that it affects all commodities, right? Every year prices increase by a rate of 2%. So I need from this, I need the real rate of interest. How do I find it? What's the relationship between these three things? Nominal interest, inflation, and the real interest rate. Can someone tell me what is the relationship? Hi, Calvin, Raphael, Gabriel. What's the relationship between nominal, real, and inflation? No one? Anyone? Did you read the textbook? Did you search for it in the index? Do you know from economics? I mentioned last class that the Fisher relation Fisher equation or the Fisher relation gives you the answer. Tiana wrote, real is equal to approximately nominal minus inflation. So that's what you learn in economics. But that's not exact. Again, she said approximate, so that's good. She said approximate. But what is the exact relationship? Nobody? You didn't look it up in the textbook? All right, so that is the relationship that you learn in economics, but that's not the exact relationship. The precise relationship is that these are rates. Okay, so you treat them like growth rates, like factors of growth. I'm going to use a different color. So the real rate, actually, sorry, it's 1 plus, right? For every dollar, the real rate, I need more space. I think I need another page. So for every dollar, 1 plus the real rate with a factor of growth, and the growth factor is inflation, is equal to 1 plus the nominal rate. So the thing that Tiana wrote was that the real rate is equal to the approximately, so you write this for approximately, is equal to the nominal rate minus inflation. Now this is true when inflation is small. When inflation is like less than 1%, this is the relationship between real and nominal rates. But in fact, this is the exact relationship right here. This is known as the Fisher equation in economics and financial economics. So now, take that equation and use the nominal rate and the inflation rate to tell me what is the real rate. So I'm turning something that was used in economics as an approximation into factors of growth, more precise. And I guess you don't learn in economics because you only have limited skills. They don't blow you away with that. But okay, so try and get it for me. Find with the information I've given you, find R. Not 1 plus RR, just RR. One mighty. So it's going to be 1.08 deflated by 1.02 minus the 1. It's always the minus 1, right? You take off the principal amount. Try it again. I gotta try and fit it all in. Sorry. I gotta make this smaller. So we deflate. This is like dividing, it's like discounting, right? If it was in time value of money, we would call that discounting. This is deflating. When you divide by a factor of inflation. Okay, good. So you guys got it. All right, so what are you going to do with that number? You're going to store it. Whatever calculator you're using, store that number so you don't lose the decimal places. Remember that you kept it as a decimal. You kept it as a percentage, sorry. So store it so you can use it. So what did you get? You said you got, it's RR is equal to 5.88 blah 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 232. So usually on exercises, on the test, I will tell you to show me as many decimals, certain number of decimals. So you just follow the directions. So now use that number to solve the problem. Let's go back to the problem. Now see if you can get that number that I gave you. 4. Can you find 4 as an annuity? 4,935.55. So what this is real cash flows with real rates. So what you're going to find is the PV at time 0 is equal to the 1,000 with the real rate. Just put the notation so you don't have to recopy it. 1 minus 1 over 1 plus R I'm going to give you a nice solution set so you don't have to have this messy one. I can't fit everything. So that's the formula you would write down in a test situation, and then entering that rate that you stored, right? So you would recall 1 and put that into interest. Make sure that it's a percentage. If it's not a percentage, if you have it as a decimal, you would have to multiply it by 100. Don't forget that trick. And put that in. So, if you did the first part, let's see if you can do part 2 or part B. Try and do part B while the others catch up. So I want to see 5 people got the answer. You want this answer here. So this is a formula for your formula sheet. The new formula is this one, the Fisher equation. That means Fisher equation. I think my feed froze because you're not seeing the whole solved problem. I have to reboot. There you go. Sorry, you didn't have the whole equation. No, you have to do the whole annuity. It didn't show up, but that's the annuity you have to put. So you enter it as an annuity, you put 6 into N, and recall 1 times 100, whatever it is, into interest. I like this green. And then PV is what you want, so leave that blank. Payment is 1,000. And then 0 into face value and compute PV. Who else got it? So the only thing you have to do is the preliminary calculation of this. You have to learn the property that real cash flows with real rates to calculate in time value of money. So if you are not writing this down, just take a screenshot. Okay, take a screenshot so then you can have this result. and then enter it into your notes. Okay, you guys ignoring me. I want to know who else got it. Are you just trying B now? So B part? So now I'm going to talk about what real actually means, because you're probably like, what is this all about? So let's talk about what real means. Good, Ivana got it. Who else got it? I want 5 people who got it. So I have 2 so far. Oh, 3. No, 2. I know some of you are resisting using the calculator. Surrender. Do not resist. Use the calculator. It saves a lot of time, and you do need to learn that skill, okay? It's an invaluable skill. Very good. Okay, so I have one more person. Who else got it? Or 2 more people. Very good. One more. I'm going to try a different software than this one, because that one I cannot shrink. What about this one? I had a nice software. I don't know. I had 2 good ones and they're gone now. I don't know what I did. I got ambitious. I deleted them. Paint. I like to be able to shrink and grow the page. I don't want to paint anything. I guess I'm back here. Okay, next problem. You guys doing this? You're not doing this? 23 of you. So let's do part B. Part B. So now you're asked show. Let me see, I'll flash the question paper. So part B says, show how to get the same result with the growing annuity formula and the nominal amounts. So what I have to do is change my timeline from real to nominal. So remembering the timeline for real cash flows was like this. I should put the tick marks first, right? 1, 2. Do this again. So what this says is that starting at year one, a person is going to have $1,000 in real dollars. What does that mean? The base year for these amounts are time now, time zero. When you talk about real, you always have to think, you have to always mention in terms of time. What is the base year? So it means that whatever I can buy with $1,000 today, I should be able to buy it with $1,000 next period. But we know there's inflation. So how much should I actually have available to me? How much should I have in my pocket? So what I want to do is write the nominal cash flows here. I feel like the page is moving. I'm moving the page, which I like. I don't know how to do it when I want it. So these are nominal cash flows that I'm going to draw now on my crooked timeline. So how much should I have if there's inflation of 2% here? So weird. Don't know why my screen is moving. So how much should I have at year one to be able to buy the same things as I bought in year zero? Well, the money in my pocket should have grown to 1,000 times 1.02. So I should actually have, to be able to buy the same amount of things, I should have 1,000 times 1.02, which is the same as $1,020. Okay? So $1,000 in real dollars, 1,000 real dollars is the same as having $1,000 in $1,020 at year one. $1,000 in real dollars at year two how many nominal dollars? So how much did I have in my pocket to be able to buy at year two the same amount of stuff that I bought in year zero? So when I say the same amount of stuff, think about if I was able to buy a computer now, today, the next period I should be compensated enough money to be able to buy a computer next period. Computer prices go up by 2% in this world, so I should be given $1,000, so $1,020, right? So how much should it be in year 2? How much should it be in year 3? What is the pattern of nominal cash flows is what I'm asking. You guys following? Are you guys watching? Can I get some responses? So what's the next one? This actually works out to be 1,000 times 1 plus pi, or we'll say 1 plus g, where g is pi, right? So it's growing at a rate of g. And the next one would be 1,000 times 1 plus g squared. And the next one would be 1,000 times 1 plus g cubed. And the next one would be 1,000 times 1 plus g 4. Where am I? Did I miss one? Oh yeah, those are not the... So this would go here, and this one would be this one. And then for year 5, so this is 1, 2, 3, 4, 5. For year 5, it would be 1,000 times 1 plus g 5. And then for the last one, year 6, it would be, anyway, hopefully you can draw it better than me. I'm making a mess. 1,000 times 1 plus g to the power 6. Okay, so you draw a nice timeline. Mine's a mess. So what are you getting? What is this? Can you guys give me a word for this? What I'm doing here? What is this? What do the nominal cash flows look like? So because there's inflation, even though someone says, okay, so I'm going to, so how is the question phrased? Let's look again at the question is phrased. A 6 payment annuity of 1,000. So let's say you're going to receive $1,000 in real dollars for 6 periods. It means that they're compensating you for inflation. They're giving you the equivalent of $1,000 purchasing power today. They're going to give that to you at the end of every year for 6 years, whoever they are. So that means, now I'm turning it into nominal cash flows. That means at the end of the first year, they're going to really give you $1,020. In the second year, they're going to give you 1,000 times 1 plus g squared. You can figure out all the amounts, but I'm just using the pattern. It's the pattern that I care about, because what is the pattern? What's the name for that pattern? Nope. What's the name for the pattern? What's constant is the growth rate, but what do we call this pattern? Very good. It's an annuity with growth. Thank you. So this is an annuity, as messy as it is. You guys should make it nicer on your page. This is an annuity with growth. So what did we learn? Well, that's not news. We already know what annuity with growth is. What we did learn is that this amount in real dollars is equal to this amount after 1 year in nominal dollars. So that is a new formula. So cash flows in nominal dollars are equal at time t are equal to cash flows in real dollars at time t times inflation, a factor of inflation for how many periods have passed. That is also a new formula for you. But you should know this concept that nominal and real cash flows are related in that way. Okay? So this is, if you're told, if you're given information about a timeline in real dollars, it means you're being compensated for inflation, and whatever it is in the annuity that you're getting is going to be adjusted so that you can buy or have retained purchasing power. So if real cash flows are the same, so if the real cash flows are constant through time, the actual cash flows you're getting have been adjusted for inflation. So in other words, you retain the purchasing power. You're going to be able to buy the same amount of stuff. You're going to be able to buy a laptop every year. And this is important, right? If you run a company and every year you want to update your laptops, then what you're saying is you want your real cash flows, real purchasing power to remain the same. Wherever you're getting that money from, if it's your budget that you're making, you're aware of adjusting for inflation every time. Okay, so the result of this problem in answering the question, back to the question, you should get the same answer in B part as you got in A part. You should also get $4,935.55 if you do it this way. You do the growing annuity with the nominal amounts and the nominal rate. So do it yourselves, and then I'll show you my answer. So you'll know you got it right if you have $4,935.55. Nominal dollars with nominal rates, real dollars with real rates. You should put this, in addition to the Fisher equation, you should put this equation on your formula sheet. Let me know if you get it. Getting it? Good, Jennifer. Keep going, the rest of you. So what you should do so that just changes it. Okay, so your price, or the value of those amounts for a growing annuity, remember you have to keep in mind what is the first cash flow. And we had and remembering these are nominal. Just a sketch. Okay, so the first cash flow, we already figured it out, was 1,020, or you could write 1,000 times 1, maybe make those look like zeros, 1,000 times 1.02 as the first cash flow. You need that for the formula. So for the formula, the first cash flow is C1, so you have to put either 1,000, 1.02, or 1,020. And then the rate, the nominal rate is so the nominal rate, and remember this is the growing annuity formula, so it's the minus G. In this case, it's the inflation rate, right? So I'm just going to write the symbols, which is fine for this sort of a problem. And then the formula says 1 plus G, so it's going to be 1 plus pi on the top. And then the discount rate on the bottom, right? 1 plus, and it's nominal dollars with nominal rates, so it has to be the nominal rate. And that's for 6 periods, and that's what you have to punch in. So putting in the numbers to simplify things, it's 1,020, 8% minus 2%, which is 6%. One minus 1.02 divided by 1.08 to the 6. Close it. All right. So how do you punch this in? If you're having trouble, I recommend start here. So you enter 1.02 divided by 1.08 equals, and then power 6. Then change the sign to a negative, and then add 1. And that will be this entire term. I think you have to put an equals in there somewhere. Maybe an equals here. I'll go back. So you say power 6 and then equals, and then change the sign, and then add 1, and then equals again, and you will have all of this, and then multiply by 1,020 and divide by 0.06. So that's how you do everything on the TIBA2 Plus calculator. If you're going to use your other calculator, where you write the whole thing out, you're not learning the new calculator, but you're getting an answer, so that's up to you, I guess, but I don't recommend it. I recommend you learn how to use this calculator. That's it. Who else got it? Tiana, Ivana? Good. Who else? So the next part, when you're ready. 2 more people. Good, Raphael. Anybody else? One more. Very good, Edwin. Okay. Now, very good. So let's do the second problem. The next problem. That's it, you guys? Okay. Let's see the next problem. So the next problem says, so these are all new parameters. The expected real discount rate is 5% and the expected inflation rate is 1%. Determine the present value of a 5-payment annuity of $500. Very good, Ariat. A nominal cash flow per year. The first payment is in 1 year. So this problem says, here are the cash flows in nominal terms. Now, they're saying it's constant, $500 every year, but nominal. So what was the point that I made earlier? What did I say here? I said if real cash flows are constant through time, the nominal or actual cash flows are adjusted for inflation and you retain your purchasing power. In this problem, however, that's not the case. What you have are nominal cash flows. So purchasing power will erode over time because of time value of money. So let's draw that timeline. To show that. So you have, now these are nominal cash flows. And you're told they're $500 every period. So what would those be? let's answer the first question and we'll go to the second part. Determine the PV of the annuity using the regular formula and the nominal amount. So those are the nominal amounts. So you need the nominal rate. How are you going to find that? They give you the real rate of 5% and inflation of 1%. But you need to have the nominal rate. So how are you going to get that? So back to that Fisher relationship. We know that 1 plus the nominal rate is equal to 1 plus the real rate with a factor of inflation. So let's use that formula. So this is straightforward, 1.05 with a factor of inflation means the nominal rate is what? $1.0605. So this has to be minus 1 because that's just 1 plus Rn. So Rn is 6%. Okay? So that's the nominal rate. These are the nominal cash flows. Put them in a regular annuity formula to find the answer. And what do you get? Oh. I have to make this a little bit higher. There you go. So what do you get? What's the value of that annuity, that timeline of cash flows? The PV should be equal to $500 over the nominal rate. I'll just put the numbers in because it's easy, right? 0.0605 in the regular annuity formula. For 5 years. So you can put this into your time value of money keys. To solve it. Yeah, 6.05 is the nominal rate. So then you use the nominal cash flows. Yes, Brian's got it. $2,103.32. Very good. Exactly 32 cents. Okay. A few more people, let me know you got it. And then we're going to outline the last part, and I'm going to leave it for homework so I can introduce the next topic in the course. Very good. So in the top row, we have the nominal cash flows of $500. But inflation prevails. So what's going to happen over time is the purchasing power is going to erode. What do I mean? It means that even though this is what I'm getting, because there's inflation, so let's say if $500 today buys an iPad, basic tablet. So if 500 buys a tablet now, I won't be able to buy the same quality tablet next period because prices have gone up. Even though I have $500, I'm not going to be able to buy that tablet like I did this year, the same quality. Okay, so not to buy a second-hand one. That's not what I'm saying. I'm saying to go buy the exact same thing, brand new. I'm not going to be able to do it because prices are going up. I use technology, but that's a tricky one because, anyway, the point is you get the idea. The same basket of goods. So I could say $500 worth of groceries, for instance, that I could buy today. I'm not going to be able to buy it next period because I only have a $500, but all the prices went up. So what is the real amounts? What are the real amount equivalents? How do I figure that out? So you use formula. How do I use this formula to figure out what is the real amount in each place? So rather than inflating the prices like we did in the last problem, I have to deflate the prices. I have to use this version of the formula. I'm going to just erase this stuff. I have to use I have to deflate the amounts as many periods as I have to. So the first amount will be 500 divided by 1.01. And the next one will be 500, it'll be smaller, divided by 1.01 squared. And the next one will be 500 divided. Now I don't care about the number exactly what it is. What I care about is the pattern, because I have these formulas I want to use. And I'm given instructions about the formula. Let me just finish writing this pattern out. This time I did a better job with the spacing. This is the more important one anyway. So this is the one a little more challenging. So these are smaller amounts. So it goes down and down and down in amount. So the problem asks you, and I'm going to leave this for homework. Show how to get the same results as you did in A, the $2,000, $2,103.32. Show how to get the same result with the growing annuity formula and real amounts. And note, the growth rate is not -1%. So I'm going to leave that part for homework for you, okay? And I'll share the answer with you like on Monday or Tuesday. But you should try and finish that yourself. Now that you're on a roll. And see that you can get $2,103 like you did in the problem here. I'm not sure why that screen froze. That's weird. Yeah, it disappeared, right? I'm not sure why. Let me... Lost the connection. So this was the first part, part A, and then I drew this. Did you guys see me draw this? I hope so. Or do I have to draw this again? Oh, you didn't see me draw that? No one said anything? I lost the connection at some point. So let's go. So I said this, and then I drew this. So what is this? Let's draw this again. So I'm drawing the timeline, nominal cash flows. And each year you're getting $500. And it means that you're just getting $500, and whatever you bought for $500 today, if there's inflation, which there is, you're told that there's inflation of 1%, you're not going to be able to buy the same amount of things. So if I put this in real terms, what does that look like? I should be using the relationship between cash flows. So the cash flow, nominal cash flows at any given time are equal to the real cash flows adjusted for inflation. This formula I gave you. But what if I want to get this amount? So rather than writing it this way, I would write it like the real cash flows, these subscripts are supposed to be helpful, I hope they're not confusing, is equal to the nominal cash flow deflated so this is deflation or deflating. So what you have to do is take the $500 and deflate it by inflation for the first period. And then in the second period, so you see these numbers, these cash flows are smaller and smaller over time. My goodness, it's hard to write in that corner. Okay, so they're smaller and smaller. So what I care about is not the value, I care about the pattern. I care about the pattern. And what pattern is this? In real terms, my purchasing power has diminished. Using the real cash flow timeline now and the growing annuity formula, how will you get the same answer? So that's what I'm giving you for homework. So again, show how to get the same result the $2,103.32 using the growing annuity formula on the real timeline. Okay? That's homework. Okay, so we have half an hour left to look at the new material. So I'm going to send you some files, unless you have some questions. Just practice, and I recommend you follow my instructions and practice it, because you're going to need to know how to do that. Yeah, sending you a whole bunch of stuff for you to work on this week. No, Jennifer, there's no growth. There's no positive growth anyways. It's not going to be 1%. Nope. But it's also not negative 1%. The amounts are going down. See? They're smaller and smaller and smaller. So you have to find the growth rate. The way to do that is to look at the first one and say to yourself, this should be the same as that to use in the formula. Remember the pattern of the formula and solve for G. Okay? Solve for G in terms of pi, because these are going to cancel. So what you're going to solve is this is your G. Oh, you didn't see what I did again. Okay, let me write it down. I'm gonna do that again. So what you want to do is say this amount should, for the formulas for the growing annuity, should be the same as 501 plus G, and you're trying to find out what the G is for the formula. So you solve this problem for G. This reduces, when you cancel these terms, to 1 over 1 plus pi on that side and 1 plus G on this side. So G is equal to 1 over 1 plus pi minus 1. G will be negative because the amounts are going down. They're getting more and more and smaller and smaller. Okay? So that's what you got to do. You got to find G and then use it in the formula, and you should get the same answer as you got. PV equals 2,103 and 32 cents. Again, nominal dollars with nominal rates, real dollars with real rates. Remember, you have to use G and you have to use the real rate. Okay, so I sent you a bunch of files. And I want to start with 2.1. Actually, you know what I want to start with? I actually want to start with the problem set. I sent you, so that's 2.1. I just want to look at the review. I sent 2.6. Let's look at 2.6 together. So you're motivated. Okay, so the question is, this is 2.6. Notice I give instructions, you see, details about how to answer the question. So read the instructions every time. This is document 2.6. Okay, let's see. The first problem, you know how to deal with that one. Let's look at question number 2. Look at question number 2. I'll wait for you guys to find it, open it. Okay, so starting 1 quarter from now, Lydia will begin to deposit $1,000 at the end of each quarter into an account to save for her retirement. She will do this for the next 30 years. How much will Lydia have accumulated at the end of 30 years? If the annual effective rate of interest is 5%. How do you solve this problem? Describe to me how you solve this problem. What formula do you use, and what are the values of your variables? I'm going to send you one more document. 213. Okay, what are you guys saying right now? Okay, so we're looking for the future value. You're going to use the annuity. So what are your what's your interest rate? What are you doing? What is the approach? Anyone? We're looking for future value. We're going to use an annuity. Like, where do you start is the question. But what's the first question? What's the first question you ask yourself? I just sent you a document, 213. I want you to open it up. So in 213, I mentioned some steps because there's lots going on here. Lots of information. And you need a systematic approach to solving problems. And so open that document and let's read through this together. Okay, you guys are writing, change everything to comply with quarters. That's right, Tiana. ¿Cuánto es un cuarto en 30 años? Yeah. Obtain the PV first. Oh, someone just gave me an answer. Okay. So, these are the steps. Step 1. Every single problem that you read, identify if there are payments, right? You're going to solve this differently if there's payments than if there's not payments. So, if there are payments, you have to convert all your rates, interest rates, discount rates, and growth rates to an effective rate that compounds with the same frequency as the payment frequency. To use the formulas I've given you, you have to do this. In the problem we just read, payments are quarterly, so we need the quarterly effective rate. And we're going to talk about what that means if you don't know. The second step is to draw the timeline and determine whether the problem involves a simple time value of money problem, an annuity with or without growth, or a perpetuity with or without growth. Then focus on the portion of the problem that uses this formula just as is. In the third step, that's when you modify. So we've already done this in the annuity problems that we solved at the beginning of the class. We used the formulas in the positions they were on the timeline, and then we adjusted them to move them to the positions that we wanted them. So we did 2 and 3 before. What I'm doing now is focusing on step 1. How do you convert all rates? Okay, questions? So interest rate conversions is what we are interested in. In this problem, in 1 quarter from now, Lydia will begin to deposit $1,000 at the end of each quarter into an account to save for her retirement. She will do this for 30 years, and I want to know the future value. So you can use the present value formulas to use in an annuity. So your answer in the chat should have been use the annuity formula with $1,000 and the effective quarterly rate for 4 times 30 periods. Compute future value. Basically, your calculator can do this automatically for you, but you have to write a formula. So you're going to have to make the annuity formula and the basic time value of money formula as one. So annuity formula with 1,000 and the effective quarterly rate for 30 years times 4 quarters a year. So that's 120 periods. Compute FV. So you should be able to talk about this stuff, not just quantitative, okay? You should be able to explain yourself. And you can do that in Spanish. I can understand Spanish well enough to understand what you're saying. Okay, so without going into this, because I will send you, you're going to work on these. I want to start with interest rate conversions. So the page, the document that I gave you is this one. This is my credit card statement, or part of it, and I have no outstanding balance on my account, which is nice. So I had no interest charges. I'm told though that if I did have an outstanding balance, the annual interest rate next period would be 18.4%, and the daily interest is 0.050411%. Which of these numbers are important to me? Which of these numbers tell me the daily, the daily interest rate? Because credit cards charge on outstanding balance, it charges a daily interest rate. It accumulates per day. So which of these numbers do I look at? This one, annual interest rate next period, APR, or daily interest rate next period? Right, so this is called, I kind of gave it away the way I explained that, but it's fine. So this is the effective daily rate. So what the heck is the other number then? Why are they giving me this other number? What's this? In a few words, tell me what that number is. And how does it really relate to the other ones? How does that number, so what is that number and how does it relate to the effective daily rate? In a few words. Somebody must know. And if you have a credit card, you should look at it. Okay, so Ariette is saying that it's a multiplication. Okay, so what it is, but I need a better word, a word that we already discussed in class. What is it? So that's the relationship. If I multiply 0.0005,041 times 365, I get 0.184. So what is it? What is 18.4%? What do we call that? So someone said it takes into account compounding. What takes into account compounding? So what do we call this? And nobody knows? Seriously? That's okay. I'm going to learn something today, right? This is the simple interest over the year. That's just the simple interest. It took the daily rate and multiplied by 365. That's just simple interest. That's not the compounded interest. So the APR, the annual periodic rate, okay, so for every dollar invested, it's just showing you the simple interest. It's just saying 365 times that daily rate. It's ignoring that the amount continues, so that there's interest on the balance, and then that interest also gets interest. It's ignoring the interest on the interest, which with small amounts is negligible, it's not a big deal. But when time passes and the interest accumulates daily, and that could be a lot of money, okay? So the question now is, what is the effective annual interest rate on my credit card? What are you really paying, in other words, per dollar if you leave it and you don't pay it off in a year? What's the effective annual interest rate? So I know it's 11:45. I'm just going to finish this. If you guys have to go, you can go. But I do want to finish what I'm saying, and then I'll leave you with all those materials to read through them in preparation for next class. So read through them, try the exercises. I gave you solutions to some. I have a lot more to give you without solutions for practice, so I'll send those along. But if you don't understand in the week, that's fine. Just accumulate your questions, and you can ask me on Friday. I just want to finish this. So what is the effective annual interest rate? The effective annual interest rate will take account of the compounding. It would be 1.00050411. I forgot the 1 up here. Let me fix that. To the power of 365. So if I did that, if I put it in powers, right? So it's a compounding thing. It's a compounding effect. It's 1 plus the interest rate compounded for 365 years. That's the same as what's known as the EAR. EAR is 1 plus EAR. Okay? So to solve for that, you would have to take that amount minus 1 to find the effective annual rate. So what do you get in this problem? I'm going to make this bigger. Okay, so the ER, it turns out to be 0.201 960276, which is 20.2%. It's not 18.4. Okay, 18.4 ignores, for every dollar outstanding, it ignores the interest charged on interest and accumulated for 365 days. So that's quite a difference if you're talking about large sums, and it's very misleading if people can't make these calculations. Unfortunately, people with this information have greater potential to be financially literate and to be financially better off than people who don't have this information. So you guys are in a select class of people who understand this. Understand your rates, understand how these things are computed for your personal life, for your business and professional life. Be aware, these are the rules. This is how, even though it's in my financial statement, it's assumed that I know what it means. Unfortunately, people who don't have this information are at a disadvantage. Okay, so that is the rate you would have to use in any of the formulas. We only use effective rates in the formula that I've taught you for time value of money. So in order to have the correct rate, the effective rates for the formulas, you have to convert them. And so I'm going to leave you to read through everything I've given you and go through it diligently. You can read the textbook too. Next week I'll post an assignment from the textbook, but right now I want to teach you all of this material before I launch into the textbook, all right? I want to teach it all to you with these notes, and please keep up, don't fall behind, because you're not going to be able to learn all this in a night or review it all in a night, all right? So there it is. You have any questions? I'm going to stay back. If people have to leave, go ahead, and you can email me too with questions or text me. All right, so have a good week. I'm going to send you some more materials. Some will have solutions, some will not. Okay, and also in terms of the problem, the discounting problem, I'll send you that solution this week, so you can study it before next class. Okay, bye for now. I'll just stay back if people have questions. Right. I guess if you don't, some people are saying they don't have Learn Smart. I don't know. I have to check with Antoinette. I'm surprised if you don't have the Learn Smart. But yeah, I'm gonna post some problems so you can practice, and they'll be due in a few weeks. She did not respond to me about Learn Smart. She's just busy, I guess, because she's dealing with all her clients in Puerto Rico. Thank you, Edwin. Thank Walter. So Ricardo, you can't get into Connect. Right, Ricardo, if you guys have problems with Connect, write me and I'll share it with the representative. She'll fix it eventually. She's really great. She's just probably behind right now. Don't worry, just keep working with my materials. You'll be fine. I won't post anything until everyone has the Connect. Right. If I'm the professor, yeah, it's the right version. Breely Myers textbook, and they only have the newer edition, I think. I don't even know. It's like 13th edition. Let me see. I have books all over here. Yeah, 13th edition. Someone just asked me about nominal, and these are all nominal rates. I haven't even mentioned real for this stuff. So effective rates are all not, like everything I've talked about so far about interest rate conversions, it's all nominal rates. Okay, there's no real stuff. If I mention real rates to you, I'll be explicit and mention it. So if I never mention anything, you assume it's nominal. Okay, so that's what I risk by teaching you inflation early. Usually I teach it a little bit later, but I like to teach it early so it can sink in. And it's also useful to teach with the growing annuities. I do have to teach you still, we have to do the last part of the notes with the annuity problem. The pension problem as well. So that's what we're going to start next week, the pension problem in your notes. Okay, I think everybody's going to ask a question. It's gone. Gonna say good day. Oh, one more. Ricardo, if it's with my name, it's the right book. I don't know what did I call it? what is the name on my Connect book? Let me see. Hold on, Ricardo. I don't know why you're having trouble. Did you follow the steps I sent, the brochure? This is what I call the course. Yeah, I did call it in Spanish. I referred to it. I wrote that. And then it says Breeley Myers, 13th edition. And then it says PS 2021. Something like that. Ricardo. Okay, bye.